Okay, let us solve the problem on finding the impulse response from the given difference equation. The difference equation here is y of n minus 4 into y of n minus 1 plus 3 into y of n minus 2 equals to x of n plus 2 into x of n minus 1. This question was asked in a UTU question paper. Let us consider the difference equation y of n minus 4 into y of n minus 1 plus 3 into y of n minus 2, that is equal to x of n plus 2 into x of n minus 1. Let us take the z transformation on both sides. Taking z transform on both sides, you get that is z transformation of y of n is y of z minus 4. Z transformation of y of n minus 1 is z to the power of minus 1 into y of z. This using time shifting property for writing this, plus 3 into z transformation of y of n minus 2 is using time shifting property z to the power of minus 2 into y of z. That is equal to z transformation of x of n is x of z plus 2 into z transformation of x of n minus 1 is z inverse into x of z. Okay. Here, let us take y of z common in the left hand side. You get 1 minus 4z inverse plus 3z to the power of minus 2, that is equal to x of z is common on the right hand side, 1 plus 2z inverse will get. Okay. You can write this one as y of z by x of z, that is nothing but the system function h of z, that is equal to 1 plus 2z inverse all divided by 1 minus 4z inverse plus 3z to the power of minus 2. Now we can find out its impulse response h of n by taking its inverse z transformation. To go for the inverse z transformation, let us factorize the denominator polynomial. This we are doing it by partial fraction expansion method. Consider 1 minus 4z inverse plus 3 into z to the power of minus 2. This can be written as 1 minus z inverse minus 3 z inverse plus 3 z to the power of minus 2. 1 minus z inverse minus 3 z inverse is common. You will get 1 minus z inverse. 1 minus z inverse into 1 minus 3 z inverse. Then we can write h of z is equal to 1 plus 2 z inverse all divided by 1 minus z inverse into 1 minus 3 z inverse. Okay. Then we can write this one here, that is h of z equals to 1 plus 2z inverse divided by 1 minus z inverse into 1 minus 3z inverse is c1 divided by 1 minus z inverse plus c2 divided by 1 minus 3z inverse. We can get the value of c1 by multiplying h of z by denominator of c1 and get the value of z inverse by equating the denominator of c1 to 0. Then you get c1 equals to 1 plus 2z inverse divided by 1 minus 3z inverse. 1 minus z inverse get cancelled. That is where z inverse is equal to 1. It will be 1 plus 2 divided by 1 minus 3. It will be 3 by minus 2. That is c1 is equal to minus 3 by 2. Similarly, to get c2 value, multiply h of z by denominator of c2, that is 1 minus 3z inverse, where z inverse is equal to 1 by 3. Then c2 is equal to 1 plus 2z inverse divided by 1 minus z inverse, where Z inverse is equal to where Z inverse is equal to 1 by 3. That is 1 plus 2 by 3 divided by 1 minus 1 by 3. That is 5 by 3 divided by 2 by 3, where C2 value is 5 by 2. Then h of z equals to C1 value is minus 3 by 2 whole divided by 1 minus z inverse plus 5 by 2 is the C2 value, 1 minus 3 z inverse. Next, taking its inverse will get the impulse response h of n as minus 3 by 2, keep it as it is. Inverse Z transformation of 1 divided by 1 minus Z inverse is u of n plus 5 by 2. Inverse Z transformation of 1 divided by 1 minus 3 Z inverse is 3 to the power of n into u of n. This completes. Thank you.